All right. All right. How's it going, everybody? Welcome back to the stream. Oh, I think I messed up here. I was supposed to change the title here. My bad. Let's go ahead and switch that up. Hmm. One sec. We're going to be doing reading Pro Git. Right. We're going to read Pro Git. All right. Hello, everybody. Welcome in today. We are going to be reading and jumping right on into Pro Git. It's going to be a great book here to get us going. I already know a little bit about Git. I've done some working with it. I use it currently in my current repositories and stuff. But I need to get a better, more deeper understanding. So this book not only has, various there's books, but also has a couple of videos to watch as well for um, Git and everything. So it should be a great time here. So let's go Pro Git chapter 1. Let's say, wait, we're reading chapter 1. Yeah, we'll just say chapter 1. All right, how about that? Let's just go to the channel. Go here. We want to pop out there, boy. All right. There we go. All right. Let's go ahead and dive on in here to Git and Pro Git chapter 1. Thank you guys so much for joining me here. Let's grab a blanket. Let's get this thing going here. We can watch some videos, sure. But I want to read the book too. More information, the better. I like reading books. Okay. Honestly, videos and lectures I snooze through. Books keep me awake. All right. We're going to be doing Git here. Let's go ahead and shift it up. Let's do the book on this side now, and let's do our notes on the right side. How about, because let's go open up we need to let's go all right. I am struggling here. Let's see, what do we want to do? Let's go over here. Folder Pro Git. chapter 1. Let's go ahead and code here. Okay, there we go. Let's go ahead, new file. Chapter 1 notes.md. Okay, cool. Let's get on into this, boys. Today is Git Day. We're going to really get into learning this, moving up into our learning. The old hat is back, yeah. Yeah, I downloaded the PDF here. But I figured it'd be kind of fun to go through this kind of way. It's kind of weird having it on this side versus the other side. We've been doing it the other way around on stream. I think I might go back to the other way. Yeah. I liked it a lot. I'm used to this. Sorry. Okay. Here we go. Chapter 1. Here we go. Getting started. About version control. All right. This chapter will be about getting started with Git. We will begin by explaining some background on version control tools, then move on to how to get Git running on your system, and finally how to set up to start working with. At the end of this chapter, you should understand why Git is around and why you should use it, and you should also be set up to do so. What is about version control? All right, here we go. Here we go. So about version control. What is version control and why should you care? All right. Okay. Version control is a system that records changes to a file or set of files over time. A system that records changes to a file or set of files over time. So, right, so that you can recall specific versions later. So that you can recall specific versions, sticky key, versions later. For the examples in this book, you will use software source code as the files being version controlled. Though in reality, you can do this with nearly any type of file on a computer. If you are a graphic or web designer and want to keep every version of an image or layout, which you would most certainly want to, a version control system is a very wise thing to use. It allows you to revert selected files back to a previous state, revert the entire project back to a previous state, compare changes over time, see who last modified something that might cause a problem, who introduced an issue and when, and more. Using a version control system also generally means that you screw things up or lose files you can easily recover. In addition, you get all of this for a very little overhead. Local version control systems. Many people's version control methods of choice is to copy files into another directory, perhaps a timestamp directory, if they're clever. This approach is very common because it is so simple, but is also incredibly error-prone. It is easy to forget which directory you're in and accidentally write the wrong file or copy over files you don't mean to. To deal with this issue, programmers long ago developed local version control systems that had a simple database that kept all the changes to a file under the version control. So you had a file, database version, 1, 2, 3, and this is the current checkout of the file. Okay. One of the most popular version control tools was a system called RCS, which is still distributed with many computers today. RCS works by keeping patch. Okay, so we'll just say RCS. RCS works by keeping patch sets, that is, the differences between files, in a special format on disk. It can then recreate any file looked like at it can then recreate what any file looked like at any point in time by adding up all the patches. Okay. So, a version control system where differences between files were kept as patch sets, right, in a special format on disk. It can then recreate what any file looked like at any point in time by adding up all the patches. Okay. Hey, Blitzengill, what's going on, man? How's it going? Good evening to you. Welcome in. Hey, Wing Hong, welcome back. DevGod, fun fact teacher, if the base camp is backwards like cool kid, learn Python 5 times faster. What? Oh, if you say the baseball cap is backwards, I'll learn faster. All right, we'll print it backwards for you, DevGod. had to deduce your English there. All right, we'll put it backwards for you. Cool. So that is RCS. That's another system here. So this says a revision control system. A revision control system. Right? Interesting. Centralized version controls. The next major issue that people encounter is that they need to collaborate with developers on other systems. To deal with this problem, central version control systems were developed. These systems, such as CVSs, Subversion, and Perforce, have a single server that contains all of the versioned files, and a number of clients that check out files from that central place. For many years, this has been the standard for version control. Okay. So the next major issue that people encounter is that they need to collaborate with others. To deal with this problem, a centralized version control system were developed. These systems, such as CVS, Subversion, and Perforce, have a single server that contains all the version files and a number of clients that check out files from a central database. Okay, so a developer could check out a file and then send it back into the database, and so you could probably only have one person check it out at a time, right? This setup offers many advantages, especially over local version control systems. For example, everyone knows to a certain degree what everyone else on the project is doing. Administrators have fine-grained control over who can do what, and it's far easier to administer a central version control system than it is to deal with local databases on every client. However, this setup has some serious downsides. The most obvious is the single point of failure that the centralized server represents. If that server goes down for an hour, then during that hour nobody can collaborate at all or save version changes to anything they're working on. If the hard disk, the central database is on, becomes corrupted and the proper backups haven't been kept, you lose absolutely everything. The entire version of the project except whatever single snapshots people happen to have on their local machines. Local version control systems suffer from the same problem. Whenever you have the entire history of the project in a single place, you risk losing everything. This is where distributed version control systems step in. Distributed version control systems, right, step in. In a distributed version control system such as Git, Mercurial, or Darks, clients just don't just check out the latest snapshot of the files. Rather, they fully mirror the repository, including its full history. Thus, if any server dies and these systems were collaborating via that server, any of the client repositories can be copied back up to the server to restore it. Every clone is really a full backup of all the data. Okay, so clients fully mirror the repository, including its full history. Okay, so you have a server computer, a version database on computer A. Okay, everybody has all the versions. Interesting. Okay. Next page. Oh, furthermore, many of these systems, you guys can't read this, it's on the bottom here, but I'll read it here. Furthermore, many of these systems deal pretty well with having several remote repositories they can work with, so you can collaborate with different groups of people in different ways simultaneously within the same project. This allows you to set up several types of workflows that aren't possible in centralized systems, such as hierarchical models. Next. Okay. 1.2. Getting started. A short history of Git. This is fun. We're learning, guys. Yeah. You never heard of RCS? Me either. Hey, DevGod. Thanks for coming in and talking with me on Twitch. You're awesome. Hey, Abyssal Phoenix. Yes, we're learning Git today. Reading Pro Git. I'm going to add this book into the Discord, link down below. So in the YouTube chat. So if you want to join my Discord to get a roadmap of all my learning so far from these past 10 months of Python and computer science self-teaching, it's all in my Discord, and I'll be adding this one after the stream. We're starting this book here. I'm gonna try to finish chapter 1 today. The whole stream is gonna be chapter 1. I want to just keep grinding through these books and learn as much as I can. Got to keep moving. Edwards, how's it going, man? Hey, Hiren Patel, welcome back in. It's awesome to hear from you again. Thanks so much for being here. If you guys are part of the early crew, leave a thumbs up on the stream. Please, please, it really helps. Thank you guys so much. I really, really appreciate you guys for helping me. You guys are awesome. Thanks, Blitz and Kill. You guys are awesome. Thanks, Tim. All right. Everybody's so nice. As with many great things in life, well, let me go ahead and bring the book up so it's not on the bottom here so I can know when to cut. There we go. As with many great things in life, Git began with a bit of creative destruction and fiery controversy. Oh, gosh. The Linux kernel is an open source software project of fairly large scope. During the early years of the Linux kernel maintenance in 1991 to 2002, changes to the software were passed around as patches and archived files. In 2002, the Linux kernel project began using a proprietary distributed version control system called BitKeeper. Okay. In 2005, the relationship between the community that developed the Linux kernel and the commercial company that developed BitKeeper broke down, and the tool's free of charge status was revoked. This prompted the Linux development community, and in particular Linux Torvalds, the creator of Linux, to develop their own tool based on some of the lessons they learned while using BitKeeper. Why would they do that? That seems so stupid. Like, knowing that guy created Linux and can just create anything like out of whatever, right? Why would they challenge and him? Because then he could just, now everybody uses Git. No one talks about BitKeeper anymore, no? Yeah. Nerd alert, right? Computer science beef. Come on. What's going on? Everybody's got beef nowadays, even devs. But why would they, you know, knowing that he could just create something so easily, like why would they even try? It just seemed like a stupid business move. Okay. So to develop their own tool based on some of the lessons they learned while using BitKeeper. Some of the goals of the new system were as follows: speed, simple design, strong support for nonlinear development, thousands of parallel branches, fully distributed, able to handle large projects like the Linux kernel, efficiency, speed, and data size. Since its birth in 2005, Git has evolved and matured to be easy to use and yet retain these initial qualities. It's amazingly fast, is very efficient with large projects, and has an incredible branching system for nonlinear development. See Git branching. Hmm. Okay, we'll just say here, um, created by um, the Linux development community in response to BitKeeper DVCS relationship fallout in the early 2000s. We'll say goals for Git were number 1, speed. Number 2 was simple design. Number 3, strong support for non-linear development, thousands of parallel branches. And then 4, fully distributed. And 5, able to handle large projects. Awesome. Adapt and improve, right? Wing Hong doesn't like anybody. Wing Hong is always that guy that's like, well, actually, I don't really like him. You crack me up, dude. You're funny. Okay, next step. Let's keep moving here. 1.3. Getting started. What is Git? Okay, what is Git? So what is Git in a nutshell? This is an important section to absorb because if you understand what Git is and the fundamentals of how it works, then using Git efficiently or effectively will probably be much easier for you. As you learn Git, try to clear your mind of the things you may already know about version control systems, such as control CVS, subversion, and perforce. Doing so will help you avoid subtle confusion when using the tool. Even though Git's user interface is fairly similar to these other version control systems, Git stores and thinks about information in a very different way, and understanding these differences will help you avoid becoming confused while using it. Snapshots, not differences. The major difference between Git and other version control systems, Subversion and Friends included, is the way Git thinks about its data. Conceptually, most other systems store information as a list of file-based changes. Most other systems store information as a list of file-based changes. These are other systems, CVS, Subversion, Perforce, and so on. Think of the information they store as a set of files and the changes they made to each file over time. This is commonly described as delta-based version control. Okay, so delta-based version. Right. Conceptually, most other systems store information. information as a list of file-based changes. Store information. So what is a delta-based version control? Tim. The delta-based version control system is a type of version that stores only the differences or deltas. Systems like CVS, Subversion, Perforce use where changes or deltas, right, are recorded. What was it? Is a type that stores only the differences between the one version of a file and the next, rather than storing each version of the entire file. Where only the differences or changes are recorded between versions of a file. Right, okay. Let's keep it going here. It's like TVA. Tim is a glazer. That's funny. Okay. So check-ins over time. So file A, there's a change here, and there's a change here. Storing data as changes to a based version of each file. Git doesn't think or store its data in this way. Instead, Git thinks of its data more like a series of snapshots of a miniature file system. With Git, every time you commit or save the state of your project, Git basically takes a picture of what all your files look like at that moment and stores a reference to that snapshot. To be efficient, if files are not changed, Git does not store the file again, just a link to the previous identical file it has already stored. Git thinks about its data more like a stream of snapshots. Right, so if you have file A, A1 gets carried over, there is no version 3, A1 was not changed, but it was changed in V4, so a snapshot was taken there. This is an important distinction between Git and nearly all other VCSs. It makes Git can reconsider almost every aspect of version control that most other systems copied from the previous generation. This makes Git more like a mini file system with some incredibly powerful tools built on top of it. Rather than simply a version control system, right? We'll explore some of the benefits you gain by thinking of your data in a way that when we cover Git branching and Git branching. Nearly every operation is local. Most operations in Git need only local files and resources to operate. Generally, no information is needed from another computer on your network. If you're used to a centralized version control system where most operations have the network latency overhead, this aspect of Git will make you think that the gods of speed have blessed Git with unworldly powers, because you have the entire history of the project right there on your local disk. Most operations seem almost instantaneous. For example, to browse the history of the project, Git doesn't need to go out to the server to get the history and display it to you. It simply reads it directly from your local database. This means you see the project history almost instantly. If you want to see the changes introduced between the current version of the file and the file a month ago, Git can look up the file a month ago and do a local difference calculation instead of having to either ask a remote server to do it or pull an older version of the file from the remote server to do it locally. This also means that there's very little you can you can't do if you're offline or off a VPN. If you get on an airplane or a train and want to do a little work, you can commit happily to your local copy, remember, until you get to a network connection to upload. If you go home and can't get to your VPN client working properly, you can still work. In many other systems, doing so is either impossible or painful. In Perforce, for example, you can't do much when you aren't connected to the server. In Subversion and CVS, you can edit files, but you can't commit changes to your database because your database is offline. This may not seem like a huge deal, but you may be surprised what a big difference it can make. That's very interesting, right? So that's how it works, is by copying the entire database over, or the entire repository into your system. You can make changes on any sort of historical level and then just sync back up when you get onto an internet connection. That's cool. So I'll say not Git, right? Systems like CSV, CVS is a delta based. Okay, Git has integrity. Everything in Git is checksummed before it is stored, and it is then referred to by the checksum, by that checksum. This means it's impossible to change the contents of any file directly without Git knowing about it. This functionality is built into Git at the lowest levels, and it is integral to its philosophy. You can't lose information in transit or get file corruption without Git being able to detect it. The mechanism that Git uses for this checksumming is called a SHA-1 hash. Okay, so we'll say checksummed, right? And then we'll say here SHA-1 hash. This is a 40-character string composed of hexadecimal characters 0 through 9 and A through F, and calculated based on the contents of a file and directory structure in Git. A SHA-1 hash looks something like this. You will see these hash values all over the place in Git because it uses them so much. In fact, Git stores everything in its database not by file name, but by the hash values of its contents. Oh. Interesting. So when commits are made, the files are checksummed, where the contents of the file is hashed using an SHA-1 hash, where changes to the file produce a new hash code. Okay. Anyone have any more information on this checksummed? Nice. You're diving into how Git works under the hood. Here's how to complete and verify what you got. When commits are made in Git, which is a snapshot-based system, the files are checksummed. This means each file's contents are hashed using SHA-1, a cryptographic hash function. Any changes to the file, even a single character, produces a new, completely different hash value. So I'll say here, SHA-1 is a 40-character string composed of hexadecimal characters 0 through 9 and A through F. And, right. And then I'll just take this example here, and then we'll say this. Perfect. Yeah, Hiron, that's a good idea. Yeah. Got it. Thanks, Hiron. You guys are learning Git here with me, and let me know. I appreciate you guys joining me here. We're learning together, and you know, it might seem, you know, do I really want to read this book and stuff? But you know, this is used everywhere, so we got to know this stuff. We got to know how to use it. We need to use it in our projects. So yeah. Git generally only adds data. Ugh. When you do actions in Git, nearly all of them add data to the Git database. It's hard to get the system to do anything that is not undoable or to make it erase in any way. As with any version control system, you can lose or mess up changes you haven't committed yet, but after you commit a snapshot into Git, it's very difficult to lose, especially if you regularly push your database to another repository. This makes using Git a joy because we know we can experiment without the dangers of severely screwing things up. For a more in-depth look at how Git stores its data and how you can recover things that seem lost, see Undoing Things. The 3 states. Pay attention now. Here is the main thing you need to remember. Okay, here you go, guys. Here's the main thing you need to remember about Git if you want the rest of your learning process to go smoothly. Git has 3 main states. Okay, so here, 3 main states. Number 1, modified. Right, modified. Staged and committed. Okay, modified means that you have means that you have changed the file but have not committed it to your database yet. Not committed to your database yet. Perfect. Stage means that you have marked a modified file in its current version to go into your next commit snapshot. Okay, you have staged it. And committed. Committed means that the data is safely stored in your local database. Cool. This leads us to the 3 main sections of a Git project: the working tree, the staging area, and the Git directory. Okay, 3 main states, and then we have the 3 main sections. Number 1 is the working tree. Number 2 is the staging area. And number 3 is the Git directory. Okay, stage fixes, commit, check out the process. Okay, I'm not sure what that means. All right. The working tree. Oh, we forgot to get the lava lamp on. My bad, guys. Yeah, right. Yeah, exactly, Iron. We'll be able to know. The working tree is a single checkout of one version of the project. These files are pulled out of the compressed database. Okay, the working tree is a single checkout of one version of the project. These files are pulled out of the compressed database in the Git directory and placed on disk for you to use or modify. Okay. So a single checkout of one version of the project the files are pulled out of the Git directory, right? Oh, of the compressed database. Of the compressed database in the Git directory and placed on disk for you to use. Staging area is a file generally contained in your Git directory that stores information about what will go into your next commit. Its technical name in Git parlance is the index, but the phrasing staging area works out just as well. Okay, so a file contained in the Git directory that stores information about what will go into your next commit. And the Git directory is where Git stores the metadata and object database for your project. So where Git stores the metadata and object database for your project. This is the most important part of Git, and it is what is copied when you clone a repository from another computer. The basic Git workflow goes something like this. You modify files in your working tree. You selectively stage those changes you want to be a part of your next commit, which adds only those changes to the staging area. You do a commit which takes the files as they are in the staging area and stores a snapshot permanently to your Git directory. If a particular version of a file is in the Git directory, it's considered committed. If it has been modified and added to the staging area, it's staged. And if it was changed since it was checked out but has not been staged, it's modified. In Git Basics, you'll learn more about these stages and how you can either take advantage of them or skip the staged part entirely. All right, 1.4. Moving up. Getting started. The command line. Okay. There are a lot of different ways to use Git. There are the original command line tools, and there are many graphical user interfaces of varying capabilities. For this book, we will be using Git on the command line. For one, the command line is the only place you can run all Git commands. Most of the GUIs implemented only a particular subset of Git functionality. Only use a subset of Git functionality for simplicity. If you know how to run the command line version, you can probably also figure out how to run the GUI version, while the opposite is not necessarily true. Also, while your choice of graphical client is a matter of personal taste, all users will have the command line tools installed and available. So we will expect you to know how to open the terminal in macOS or command prompt in PowerShell in Windows. If you don't know what we're talking about here, you may need to stop and research that quickly so that you could follow the rest of the examples and descriptions in this book. So I'll just say here for 1.4, the command line will be used as our primary interface for interacting with Git. 1.5, getting started, right? Installing Git. Before you start using Git, you have to make sure it's available on your computer. Even if it's already installed, it's probably a good idea to update to the latest version. You can either install it as a package or via another installer, or download the source code and compile it yourself. Installing on Linux, installing on Mac OS. There are several ways to install Git on Mac OS. The easiest is probably to install the Xcode command line tools on Mavericks 10.9 or above. You can do this simply by trying to run Git in the terminal for the very first time. So let's do this. Let's go git -- version. Here we go. We have Applegate 154. If you want a more up-to-date version, you can also install it via binary installer. A Mac OS Git installer is maintained and available for download at the Git website here. All right, I think we're okay here. I don't think that's for us. This is on Windows, yeah. So let me just take this line here I said. Just to keep the notes consistent, we'll just say this, right? And then I'll copy in my version. Cool. One 1.6. Getting started. Right, first time git setup. So we'll use this this repository we're currently working in, this directory, as our guinea pig for actually doing a Git repository and learning it, like how to do it from. I've always just had to look up on GPT and stuff, how the commands, and I've been able to do it. I've set up and have Git repositories linked to my GitHub currently, so it's nothing new, but I want to know actually like what is going on here and what's all the ins and outs. Now that you have Git on your system, you want to do a few things to customize your Git environment. You should have to do these things only once on any given computer. They'll stick around between upgrades. You can also change them at any time by running through the commands again. Git comes with a tool called git config that lets you get and set configuration variables that control all aspects of how Git looks and operates. These variables can be stored in 3 different places. path.etc/git config file contains values applied to every user on the system and all their repositories. If you pass the option -- system to git config, it reads and writes from the file specifically. Because this is a system configuration file, you would need administrative or super user privilege to make changes to it. The git config or config git config files specific personally to you, the user. You can make git read and write to this file specifically by passing the global option, and this affects all of the repositories you work with on your system. The config file in the git directory, that is git.git/config, or whatever repository you're currently using, specific to the single repository, you can force Git to read from and write to this file with the -- local option. But that is in fact the default. Unsurprisingly, you need to be located somewhere in a Git repository for this option to work properly. Each level overrides values in the previous level, so values in .git/config trump those in the path etc. config. On Windows system, okay, whatever. You can view all your settings and where they're coming from using this command here. So git config --list --show origin. Okay, so here's all the files that it's coming from. Huh. Interesting. The first thing you should do when installing Git is to set up your name and email address. This is the most important because every Git commit uses this information and is immutably baked into commits when you start creating. Git config -- global username John Doe, git config global user email John Doe example. Again, you only need to do this once if you pass in the global option, because then Git will always use this information for your user on that system. If you want to override this with a different name or email, for the specific projects, you can run the information with the -- global option when you're in that project. Many of the GUI tools will help you do this when you first run them. So did I already have that? Does it? Your editor. Now that your identity is set up, you can configure the default text editor that will be used when Git needs you to type in a message. If not configured, Git uses your system's default editor. If you want to use a different text editor, such as Emacs, you can do the following. On a Windows system, if you want a different text editor, you must specify the full path. In case of Notepad++, okay, we don't need to worry about that. Hey, Oskav. Welcome in, dude. By default, Git will create a branch called master when you create a new repository with Git in it. From Git version 2.28 onwards, you can set a different name for the initial branch. To set main as the default branch name, do this. Checking your settings. If you want to check your configuration settings, you can use git config -- list command to list all the settings Git can find at that point. So let's try that one. Git config -- list. Okay, right? I have no idea what that is, Oscar. Okay, cool. You may see keys more than once because Git reads the same keys from different files. And config, for example, in this case, Git uses the last value of each unique key it sees. You can also check to see what Git thinks a specific key value is by typing git config key. So we could say git config username, and that'll give you Michael Deming here. Michael D. Deming. That's my GitHub username. All right. I'll have to come back to this 1.6 and get some notes for it. Helpo. Getting help. Okay, if you ever need help with Git, there are 3 equivalent ways to get the comprehensive manual page help for any of the Git commands. Git help verb, git verb help, man git verb. For example, you can get the man page help from the git config commands by running this, git help config. These commands are nice because you can access them anywhere, even offline. If the man pages in this book aren't enough and you need an in-person help, you can try the #git, #github, or #gitlab channels on the LibreChat IRC server, which can be found at this. These channels are regularly filled with hundreds of people who are all very knowledgeable about Git and often willing to help. In addition, if you don't need a full-blown man page help, but just a quick refresher on the available options for a Git command, you can ask for more concise help with the -h option, as in git add -h for help. Usage git add options. So I can do these. I can do Huh. So we'll say get help say 3 ways to get help. Number 1, get help verb. 2, get verb dash dash help. 3, man get dash verb. Right, we'll say like get help config. Right. You can a more concise we'll say a quick refresher on the available options for a git command can be called with the -h as in git add -h. Okay, cool. All right, and then we're at 1.8 here. Look at that, guys. Ooh. Summary. Okay, summary. You should have a basic understanding of what Git is and how it's different from any centralized version control systems you may have been using previously. You should also now have a working version of Git on your system that sets up your personal identity. It's now time to learn some Git basics. So next will be chapter 2. Nice. Okay, let's go back to chapter 1.6 here. Let's get some notes for 1.6 because I'm kind of lacked on the notes there. So let's say now that you have Git on your system, you want to do a few things, customize your environment. You can do these things once on your computer. You can also change them anytime. Git comes with a tool called git config. So we'll say git config a command tool that lets you get and set configuration variables that control all aspects of how Git looks and operates. These are stored in 3 places. Number 1 is this guy. Right? Number 2 is going to be this guy. Or this guy. And then number 3 is going to be config file. In the Git directory. File. This is the file. If you pass the option -- system to git config, it reads and writes from this file specifically. Because it's a system configuration, you need administrative permissions. So what is a different text editor? Thanks for coming, Hiron. Appreciate you stopping in, dude. Awesome to hear from you, and thanks for coming in, man. Awesome, truly. Have a good night. Awesome. Um, so does git config auto sync to GitHub? Nope. Right now, my Git email and username locally are the same as my GitHub. Like this. Huh. Okay. Cool. So let me add this pic here. And this goes in 1.7. Get that. Okay, perfect. So now if we go Shift Command V, there's everything. Looks good. Okay, let's get rid of that. We'll just say learned about the history and setup of Git. Perfect. Okay, so let's go Git init. Right, we want to create a repository here. So I'm not going to move on to chapter 2 yet. Oh, so yeah, type git init. This creates a new subdirectory called git that contains all of your necessary repositories. A git repository skeleton. At this point, nothing in your project is tracked yet. See git internals for more information about exactly what files are contained in the git directories you just created. If you want to start version control of existing files as opposed to empty directory, you should probably begin tracking those files and do an initial commit. You can accomplish this with a few git add commands that specify the files you want to track, followed by a git commit. We'll go over what these commands do in just a minute. At this point, you have a git repository with tracked files and initial commit. So what does this do? Adds all files ending in .c to the current directory. Oh, okay. So let's just do git add oh wait, I didn't want to do that. How to delete or a git commit or git init. Okay, so we'll do this here. Okay, so no. And then LSA. Okay, so we want to go back a folder, right? Because we want to make the repository be the pro git folder. Right. Which is here, chapter 1. So pro git, this is where we'll get init. There we go. So now we have all of this within pro git. Now we'll git add, right? Git add license. Oh, this adds the license if you have a license file. So git commit -m quote initial commit. We'll say chapter 1 complete. Perfect. All right, and we'll read chapter 2 tomorrow. Nice. Sweet. We are learning it, boys. Elite? Oh boy, elite. I don't know, maybe. We'll see if we have an easy one here. Let's see. I'm not gonna wreck my brain here. Let's see. All right. This is our current leak code. We are on, what are we on? Linked list cycle. Given the head of a linked list, determine if the linked list has a cycle in it. There is a cycle in a linked list is there is some node that in the list that cannot be reached, that can be reached again by continuously following the next pointer. Internally, position is used to denote the index of the node that's tail next pointer is connected to. Note that position is not passed as a parameter. There is a cycle in a linked list if there is some node in that list that can be reached again by continuously following the next pointer. Right? Boom. Internally, POS is used to denote the index of the node that tails next pointer is connected to. What? What is this language? POS is used to denote the index of the node that tail's next pointer is connected to. Oh, okay. Note that is not a pass. Return true if the cycle is a link. There's a cycle link. Otherwise, return false. There's a cycle on the linked list where the tail connects to the first node. Oh, so the position in the variable is where the cycle is going back to. Okay. So let me see here. Are all values unique? Because if we've seen values before on a node, we don't have access. Is not note that POS is not passed as a parameter. Is used to denote the index of the node that's tails. So has cycle given some head node? And given some head node, we need to determine that there is a cycle in this list. So if we continually call next, we'll end up back here. So the thing is that's interesting though. So right, is if we travel down and we just technically keep looping around this here, how can we know that we have reached back to this index value? POS is used to denote the index of the node that's tail. It passes a parameter. So if the list never equals none, right? If the next value never equals none, then you have a cycle. Right? So if the next value never equals to none, then you know you have a cycle at some point. Now, how do you determine how many checks you do before you give up? Right? Because you can infinitely call next, and if it never equals none, well, at what point do you say, okay, enough is enough? We have a cycle here. Well, how can we determine and we're given some position, but we aren't able to access this position because it's not a parameter of this function. So we basically want to look for the pattern, right? So if we travel down, we know we have 204, 20 negative 4. It loops back Well, that would be right. So now, so Mahana is saying that you can make a node that you visited, right? And if you come back to that node, then you bid it. But you know, I'm not sure if that would work because if you have like you would say, okay, if I visited, I would save this node here with a value of 2 and a next of 0, next of with a value of 0. Are all values unique? So the number of nodes in the list is a range of 0 to 10 to the power 4. Hmm. Hmm. Given the head of a linked list, determine if the linked list has a cycle in it. So if it doesn't break none. So obviously if you have a cycle, your next value will never equal none. But at what point have we fed up and we said, okay, how can we determine now if we loop back and and so the only way I'm thinking of, right, is if we loop back, you need to determine that that sequence on the loop is the same as a sequence within the initial parse, right? Because nothing is stopping from technically this linked list from going 3 to 0 negative 4 to 0 negative 4, right? And so then in theory the loop, like if it didn't have a loop in it, it would have a repeating sequence. And so, you know, interesting. So we need to basically create an array, but it wants it in O of 1 memory. So I don't want to save the values of each node in an array and then find a slice of that array that is being repeated over and over again in some sort of looping fashion and then say, okay, true, we have matched a slice a few times now, right? Huh, interesting. Yeah, when you have an infinite loop, right? So at what point do we want to say, like, okay, it's done, like we're not going to exhaust any more resources into this yet, right? Hmm. So if we're on a head value and all we know is it's next and it's not none, we can travel. How can we know if we've gotten back, right? Like it's not saying that every value is unique in this linked list, even though the examples are given us that way. but I don't think we can assume that. Hey, Jimbo. How's it going, dude? Thanks for stopping in. I appreciate you being here. Anybody have any ideas? So we're trying to determine if it has a cycle in it. If the next value is never none, obviously there's a cycle, but at what point do we stop the infinite loop and say, okay, it's done? Like we know we can determine that it's, or what kind of key. Yeah, virtual. I have a Discord link below. Feel free to hop in there. It's got all my resources in there. It's got over 500 people from the stream and community. It's got a lot of great stuff. Weekly breakdowns of my CS50 courses and everything. So you're saying that if now what if there's an edge case that you come across that node and by chance there is another. So you're saying that if we come across, we're on this 2, the 2 points to 0. So we can save that node as a seen node. But what if, like, somewhere in this another node points to 2, 0? So, if you move next and it is a seen node, like what if this is 2, 0 and then this node is 2, 0? Well, then technically you'll hit that. Oh, okay, Wang Hong, that's a good idea. So if we move a pointer through this linked list really fast for, let's say, a 2-to-1 speed, if we ever catch back up to our value, then there is a cycle, one of our lagging pointers. So if we move a value, a pointer 2 spaces for every 1 space our first pointer moves, if at some point it catches back up, okay, that's a good pattern. Okay, so we'll say we need to go through. So um, what do we say? How can we move through this linked list with a pointer, right? And then how can we? So how can we move through with a pointer and say while okay, so let's have our leading pointer. So we'll have in the comments here, we'll have um, while head dot next, or let's say head is equal. So we'll say lag is equal to head, and lead is also equal to head, while lead is not equal to none. While lead, yeah, is not equal to none. We're gonna say lead is equal to lead dot next lag dot next. If lead equals to lag, turn true. false. Infinite loop. Come on, break out of it. Okay. So we say a lag is equal to head, lead is also equal to head node. While the lead does not equal to none, we call lead.next and lag.next. If lead so we call next.next. So if let's say, okay, so let's say in this case we call next.next. So, right, our problem's in our loop here. I'm going to take this, I'm going to go over to here. This is what 141? All right, let's say, oh, I don't have the linked list here. Oh, it's going to be hard to debug. Ah, shoot. Okay, so let's say, so I think it's because it's saying lead is going next. There's lead. Lag is going next. Oh. Lag. Lag.next. So we say resave lag. None type attribute has no next, right? Okay. So then we say if lead is none, right, we return true. Let's go here, x, here, if lead or none, return true. We'll overload that. On none attribute has no attribute next. Okay. So we're getting this fail here. I can't call next on a none. So I guess we'll say if lead dot next is none, right? Then we will return true here. I guess we can say we will remove that there. And let's try that. Right. Invalid syntax. If or, whoops. So let's say while lead not next dot next not equal to none, right? That'll take care of that for us and break out of the loop. We call lead dot next, and we say, or if lead is none, if lead is none, or lead is equal to lag. None type attribute has no next. So we call next dot next on none. So while two spaces in front of lead is not none, we'll call it and then call the lag. If lead is none, so what was my error? None type attribute has no attribute next on lead.next. So then if we say, well, its next is none, if lead is none, then okay. There you go. Boom! No! Okay. So for a blank head, okay. So we say if head, do this. Ooh. While lead. So do we want to just have a check out front, or is there a better way to do it? So if head, then go ahead. If not head, so no head. Okay, past that. No. Got a false for this one. All right. So expected is false. I got true here. Return there is a cycle. There's not a cycle. So I said there is a cycle here when there shouldn't be. So it calls lead.next. If lead is none, return true. This is outputting true. Oh, so if there is a cycle, hold up. If there is a cycle. Oh, so we return false if there isn't a cycle. And true, no. If lead is none, we return false. but if lag equals to lead, we return true. So we say return true if lag, or if lead is none, else false. If lead equal to lag, false. Let's go to my submission here. Let me use this test case. Let's run. Baby, we can do it. True. No, it doesn't like my syntax. Try to be fancy with it. So we'll say if lead is none, right? That means we're going to return false. There, it's not. If or if lead is equal to lag, we're going to return true. There we go. Baby, we can do it if you tried. Nice. All right, so this one was the tortoise and the hare pattern. I forgot about that one. We've only done one other tortoise and the hare problem, I think, so far. So that was a pattern that we haven't used so far. So you have a lag and a lead. We move the light lead 2 steps further than the lag. If the lead ever catches the lag or laps it, we know we have a cycle. Yeah, Mom, we got it, bro. No worries. We're just working through the problem. So I'll chill. Hey, Tushar, what's going on? Jeremy, how's it going? No problem, dude. We've been grinding out our final project too. Here, let me show you. This is our small business manager, our CS50X final project. We completed the income statement portion yesterday. So we are able to take in inventory items. We are able to then transact and return those inventory items multiple times even, and then populate and make appropriate income statement based off of those transactions. And it'll dynamically also work for increasing years. Baby, we can do so. So now we're gonna do the balance sheet. That's probably tomorrow assignment. Sweet. All right, so we answered this one. Kind of in the ballpark here. So we're right in the bell curve. Baby. Hey Muna, Hyper Curiosity, how's it going? Are you learning Git? Yeah, so we finished and read chapter 1 today of Git Pro Git. So we read, so if you want, just go back to the first hour of the stream. We read the entirety of chapter 1. It was really quick, really easy. It only took us about an hour to finish, and we read chapter 1. So tomorrow we'll read chapter 2. But yes, and then we finished this leak code problem here. Has cycle. No, I do not. I don't really use AI to code. I will use AI to prompt. You guys will see me often say like this, don't show me code, but I am working on leet code problem, what was it, 141, and I want you to gauge my understanding with my current attempt. And right? So then I would paste in my idea, right? And then I would paste that in. I'd say, nice, working on perfect. So it would gauge my understanding without showing me ever code, so I can walk through it myself, understand what kind of questions I should be asking myself. But we solved this one without that today. I'll usually go to that one if I get stuck after like an hour or so. All good, Hyper. Yeah, I have a degree in human biology and a minor in chemistry. Thanks so much for everybody for being here. If you're here, leave a thumbs up and consider following along and subscribing to the channel. I really appreciate you guys joining me. We're at 1639. If someone would like to be the 1640 magic number, now's your chance. Thanks so much for being here, you guys. We started the stream off by reading and jumping in and finishing chapter 1 of Pro Git. So I'm going to be uploading the repository for our notes. So been taking notes. I took notes for chapter 1 like we normally do. So chapter 1, obviously, as you can see, I have a good chunk of notes here for each little section: 1.1, 2, 3, 4, 5, 6, 7, and finally the summary 8. So really quick and easy chapter, just getting some background of what Git is, when was it developed, why was it developed, and then how to kind of get it installed. I already had it installed with the Apple Git via my laptop, my MacBook, and just some general notes here. So once I think in chapter 2 we're going to start. I initialized a repository already. I moved into chapter 2 to do that, but tomorrow I'm going to push this to, or do you guys want me to do it tonight? I could push this to GitHub tonight. And I'm also going to paste in the Discord link down below if you guys would like access to all of my study resources. I have weekly updates of all of my CS50X progress so far. I've got books all the books that we've been reading so far. So I'm going to add in a Git section or a version control section, probably is what I'll say, and then I'll have a Git book right there. I'll add it into the Discord. So link down below if you guys want to join that. Thank you so much for being here. Finishing machine learning trading strategy project has been a sweet intro to machine learning. Nice, dude. You're going to be in the quant field sooner rather than later, building some trading algos. Sweet, Jeremy. Thanks for coming in again. Yeah, Muna, it's a free book. It was you can also download a PDF version of the Pro Git, just like you would find just anywhere in the book. It's the same stuff, but I thought it'd be fun to use the website version. It just, it's kind of fun that way. But yeah, it's all the same stuff is here. I'm gonna post this this PDF though in the Discord. All right. Cool. So I think I'm probably gonna wrap it up here, you guys, for tonight's study session. We, little by little, we're gonna keep chunking along here. It's nothing too crazy. After my 9 to 5 job as a formulation chemist, I just am studying on my own here. So like I said, we read chapter 1 of ProGit and we completed a LeetCode code problem. Yesterday we did a 2.5 hour long working session or programming session on the Small Business Manager and completed the income statement portion and got the ability to actually return transactions rather than sell as well, and indicating inventory or sold status of those items, and then appropriately reducing or incrementing cost of goods sold depending on returns or sales, right, given in those calendar years. So it's really, really cool. Now there are some edge cases like that, right, there are some edge cases like, nothing stopping the user from buying an item and then selling it in the past right now. Now, would a user ever really do that? Not really, but we should probably put in some edge cases or really tone in on a lot of those different slight parameters that need to be updated regarding this. And I'm also considering, I think I'm going to expand this window about another 50 to 100 pixels to the right, and then so I can increase this matrix in size just so that the transactions and everything isn't so clumped together. I think that'll help the matrix. I think it can be a little bit bigger, and that'll help too. So yeah, so tomorrow my goal is after we read chapter 2 is we'll work on the project rather than doing LeetCode. We'll do project tomorrow after we read Pro Git, and then we'll keep moving on. I'm still going to be reading my Fluent Python and DSA in Python. Those ones are never ending. Those books are big and nice and dense, so we'll continue on with those. But I wanted to, really take a stab at just grinding through, learning Git like through and through, reading the manual, and really getting a solid understanding of what it is so we can really start using it in our projects, especially when we open this up after we submit it for our final project of CS50X, when we open up this project to be open source for the channel and for you guys to also contribute to after we get, after we submit it. I think it'll be really, really, we need to have Git knowledge then. Tushar, it's really not too hard. It's honestly, it's a lot similar to Discord. It was kind of, it was daunting at first. I was like, oh, I don't want to learn another thing, but it's really, really easy. It's pretty intuitive. It's just hashtags like you would in HTML or whatever are heading sizes, kind of like H1, H2s, H3s. So 3 hashtags is smaller, 2 is larger, and 1 is the largest heading. Then you can just do, these are like bullet points, and then you can indent in and do numbers, and then it really kind of formats it for you. And then you can just do these little backticks to kind of display like code chunks. And then you can specify also, like, I think you can do backtick, is it Python? Or is it Python backtick or something to actually display the Python syntax in that code block? So it's really, really intuitive, easy, not too hard. Anything else you guys want to talk about before we wrap things up today? Let me know. The time is yours. Thank you guys so much for being here. Leave a thumbs up before you guys head out. But I really, really appreciate everybody joining me here. Everybody, what's you guys working on? You guys got anything to talk about? Let's talk about it now. Anything you guys want me to work on or consider studying or adding to the Discord, let me hear it. Speak now or forever hold your peace. How are you guys doing? Can we get some push-ups? Yeah, I need to do, I had actually a goal I wanted to do, I thought it'd be, it's kind of a silly little fitness goal, honestly, to do like 50 push-ups at the end of every stream just to help out, keep me active. But I stay pretty active walking around. I'm on my feet all day at work, and I'm pretty skinny, but yeah. Now that you've been through CS50 and exposed to different technologies, is there a type of work you lean towards more? What about joining gym? Dude, let me just, I'm personally, I just hate working out, dude. I don't know. I just don't like it. I'm gonna say a wimp when it comes to it. I really like mental workouts and learning stuff, but I just physical workouts. I played basketball all the way through my whole youth and stuff, but once I got into college and it just dropped it like a bad habit. Yeah, we definitely need a bulk season, Chris. Thanks for coming in on Twitch and hanging out with me. Um, yeah, my roommate was a pretty big and bulky guy, and he was really strong, and he would get me to go to the gym sometimes with him, but I just would fade out over after a few times. I'm just like everybody else. I'm a normal guy. Oh, the gym. There's a gym at my work, so I I could use that rather than pay for one, but dude, it's I keep making it sounds like I'm making a ton of excuses, but I promise I'm not. I could work out on like my lunch break, but that's really like one of my few times I get to kind of just chill and just kind of relax because I wake up at around 7 a.m. I get out the door by 8. I get to work at 9. I work from 9 to about 4:30 or 5 typically, and then it takes me about an hour to get home, so I get home at around 5, 6, and then I walk my dog, get something to eat. I hop on stream at 7. I stream until about 9:30. I hang out for about a half hour, 45 minutes. I go to bed, and I repeat every single day. So the only time I could really justify, um, the only way I could really justify going to the gym is at work during my lunch break. But like I said, is I'm eating like that's like I'm eating during that time, and then I get like another 30 minutes just to relax before I got to get back to work. So yeah, right, Chris. It's you feel me. The 1 hour commute each way is brutal. That's where I'm really losing a lot of time is unfortunately with the Bay Area traffic and I don't live that far away from my work. It's only, without traffic, 25 minutes, but with traffic it takes me an hour each way. So I burn 2 hours a day just commuting, and then by the time I get home, I take my dog out, eat some food. It's time to hop on stream and study. And then by the time I get off, I got about 45 minutes to watch a little bit of The Office or Family Guy or The Crown and hit the hay and repeat, man. What do you guys recommend? Anybody have any good tips for staying active and keeping up? Dude, let me tell you, I can be your guys's, uh, you know, I can be your guys's accountability for studying and keeping yourself mentally active, but physically, I am not the guy to look to for that. um, Jeremy, congrats on the progress in an era where many won't take the time to grind like this and will instead fall back on AI. Thanks so much, Jeremy. Yeah, I really just wanted to make something, I just have a really, even if I was able to make something cool with AI, I think I would have a hard time accepting that it was truly mine at the end of the day. I currently have this ongoing mental battle. Even when I get slight help from the AI with like just basic text prompts for, explain this to me, I still get a little bit of like, is this what I should be doing, or should I really be just, aimlessly struggling and searching up answers on forums rather, but you know, it's a tool that's given to us, so it'd be unwise not to use it for those lookups and quick lookups and things like that. But no, I definitely I've been sticking to my guns here, and I've been really committed to making projects on my own. Something I'm proud of. I'm really proud of this. I've been working showing my dad, who's an accountant, and it's really cool, and it's basically an entire ledger for a business. Um, and they will be able to, small business users that don't normally have taxable and like knowledge or accounting knowledge won't have to worry about this. They just input their inventory and expenses and their transactions, and then all of their information that they hand over to their accountant at the end of the tax years is automatically generated for them just based on what they put in. So I really wanted to make that for someone like my girlfriend who's doesn't care to learn about accounting principles to record all this stuff. This is perfect for someone like that. It's perfect, hopefully. What's the weather in my area? It's starting to heat up here. It's just got to about 70 today, so it's nice. Oh, Mahan, you don't even know, my friend. Here we go. Ooh, I've got a stand-up desk. Have I ever used it? No, I have not. I got one though. Let's see how I can go up here. We can stand up here. Look at that. Yeah, this is kind of nice, actually. I should do this more often. It's not too bad. Oh, my light's falling over, though. Hold on. Got to give ourselves enough slack here. Oh. How high can these come up? There we go. There we go. There we go. Okay, that's as high as it'll go for the light. The desk goes up pretty dang high here. Wow. Oh, but that is starting to pull. Oh, see, stuff's starting to go haywire here, boys. Stuff's starting to go crazy. No! Drop the lava lamp. All right. Look at this. Look at this little setup we got going on. Standing setup. Nice. Adric, thanks for coming in, dude. Appreciate you for joining me, and consider following along if you want to be number 1640. We're almost there. We've been stuck at 1630s for a while now. But yeah, we've been learning about, 9 months or so. One more hour. I don't know if we can do another hour. You guys are, let's see here. My dog's like, what is going on? All right, let's see here. Let's see. If the next one's easy, I'll take a crack at it. If it's hard, I'm not going to take a crack at it. Difficulty. Easily. Binary tree pre-order traversal. It's got a lot of high percentage here. Given the root of a binary tree, return the pre-order traversal of its nodes. One, two, four, 5, 6, 7, 3, 9. Didn't we already do something like this? Adric, 1640, Mr. Adric. Adric, 1640. That's your number, my friend. Wear that with pride. Okay, so in this one, let's look up pre-order traversal of its nodes. So I'm going to go into my DSA in Python book. Let's go back to chapter queues. Here's trees. Pre-order. Breadth first, post-order, pre-order. Okay. So our book says, in a pre-order traversal of a tree T, the root of the tree T is first visited first, and then the subtrees rooted at its children are traversed recursively. If the tree is ordered, then the subtrees are traversed according to the order of the children. The pseudocode for the pre-order traversal of the subtree rooted at position P is shown in code fragment 8.12. So pre-order of tree at given position. So in this case, we are given a node, value left and right. Okay. Perform the visit action for position P. For each child in the tree, for its children, do pre-order, recursively call on this child. Okay. So then you go paper, title, abstract, boom, down, over, boom, down, over, boom, down, over. Okay. Where the children of each position are ordered from left to right. root of the tree is visited first, and then the subtree is rooted at its children are traversed recursively. Okay, so let's pull out the whiteboard. Let's talk this through. Just gather our ideas, right? So in this example here, we go 1, 2, 4, and 5. So, right, we need a condition. So let's say if your node equals to none, right, what are we going to return? If the node is equal to none, we're going to just return back to the previous node. Just return, right? If the node has one child, so you call left first and then right. If left, you call left. So node with one child, right? You return, what do you return? You call PT of left if left, else PT of right, right? On a node with two children, you call PT left so in this example, the 1, 2, 4, 5, 6, 7, 3. Okay, PT left plus PT right. Right? And then on a node with no children, right, we're going to return we're going to append the value, right? So this goes 1. So whatever node you visit, you get the value. So no matter what on a node, you get its value and append. So a node with no children, a leaf node, return so on a leaf node, you just append the leftmost value, you append the value. So if you come to, you append, you append, you append, okay, let's think. Okay, so what's our base case? Mahan, should we should we have a helper function? Like what in tree recursion, what indicates the use of a helper function? Like what's a good, like, oh, this would be good for helper, like, right? So let's say, let's first visit this. Okay. So we're going to have a results is equal to some array. We're going to have some array def pt given some node. We're going to say node dot if node is none, right, return back. Else we're going to node dot value results dot append the node dot value, right, append node dot value. And then we append the value and we say if node dot left and node dot right. And then we're going to return pt node dot left plus pt on node dot right. We then say if node dot right dot left or node dot right, return pt node dot return pt if return if they're either or, we want to return pt node left if no, let's say this, left equals pt dot node left, right? pt node right. If left and right, pt on left plus pt node plus pt right. If node or left, we're going to call pt on left. If left, else pt right. And so in the last case where you're on a node that has no left or no right value, you just return. So on a leaf, you just return back after you append to results. So then we're going to call so let's do this. Let's do PT results here. If the node is none, you return an empty list back. You return an empty list back. Oh, I need to sit down. We're sitting down. So if the node is none, we're going to return an empty list back, which is going to house, we're going to return results back. Or maybe we don't even need to return results here. You can just return an empty list on a value of none. It comes back so it returns a list back to you here for the left. So if this is an empty list, well, I don't know. Let's go back to what we had before. So we have def pt on node. If node is none, return back to the previous node. Right, else we're going to append the value of the node right away. Call left, call right. If there's both, you call it on both and add them together. If left or right, return left, if left, else pt right. And then if the node itself just return nothing. So then do you call pt on root, return pt on root, and then return results. No way. Dude, no way we solved that first try. Yo, you gotta leave a like for that. What? Yo, we solved that first try. Woo! Yo, that's crazy. Yeah, that one was a lot easier. We're getting, I mean, it just goes to show you we're picking up these trees a lot better. We're able to identify and create helper functions to do the traversal. We're identifying our cases at each node as we visit them and what we're trying to accomplish at each visit. And we're also identifying what we need to do to move forward to the next node, right, to accomplish our goals. So let me see this. This is 144. How does my solution look for LeetCode problem 144? Don't show me code. Your overall structure is almost there, but it looks like you're mixing two different strategies. Since you're already mutating a shared list results, you don't need to return anything from the recursive function. Just visit node left and node right in order, and you're done. Sure. If the node is none, stop. Visit the current node and append its value. Recurse left, recurse right. No need to return anything from the helper. Append node value. Call helper on node left. Call helper on node right. So it's saying that we can just say if none, append results, call and return this. Yeah. Saying PT node left and node right. If node is none, return. Rules on append node value. Oh, you just say PT node. Call PT. Then continue go. And append. Oh, because you don't need to unfold. You can just. Oh, I get it. Because you don't need to unfold the recursion and return values back. You're just collecting them as you go, and once you visit, then you're done. Ah. All right. So we got two. Okay, got you. Got you. So we don't need to unfold the recursion because our goal is just to visit every node and get its value. Left first, then right. Exactly. The goal is to visit each node in pre-order, root, left, right, and then assign, and since you're modifying the results list directly, you don't need to worry about unfolding or collecting return values in the recursive calls. The recursion works just as a stack, handling each subtree one by one. Perfect. Interesting. Yeah, so we can clean up our solution even more. So our first one, right, rather than having each of the cases for, if they have two if they have two uh, children, or if they have one child, or if they have no children, right? We can just call left and right because we don't need to unfold anything and return values into a list. We can just append the values as they're visited on each node. Hey Armando, welcome back, dude. All right, Mahan made me stay and do one more, so leave a thumbs up for the extra problem for today. We did a lot. That was a really good working session we got done today. So we did 2 LeetCode problems. We did pre-order traversal of a tree, and we did the circular linked list. To solve the circular linked list one, we had to do the tortoise and the hare pattern, and then we solved binary pre-order traversal. So tomorrow we'll solve the post-order traversal. So leave a thumbs up for the double LeetCode problems for today. That takes us to a total of 39. We're almost to 40. Soon we'll be to 50, and then from 100. If we can hit 100 LeetCode problems by our 1 year mark, that'd be awesome. So I think that'd be a great goal to set, is 100 LeetCode problems completed by 1 year. And then also my goal is to complete, well, I've got a lot of goals. Honestly, I have a goal to complete DSA in Python. We're on chapter 10. So, right, I which is really nice, you guys. It's showing that this reading is actually working, and I'm actually learning from this studying we're doing, because I was able to remember, oh, let's go back to chapter 8 on trees. Let's look up pre-order traversal. I remember reading about it, and let's just see what it was. Look at the pseudocode for the pre-order traversal that they gave. And so we were able to understand, oh, we had to go to each subtree, right, by what it gave. So it was really nice, right? For every child in the pre-order, or that's in order here. Here's pre-order. For every child, you do the pre-order, right? So that's exactly what we're doing here, right? We're just calling pre-order on left, pre-order on right after we append the value. So it's really nice. And then like I say, how much further do we got? How many chapters are in this thing? So we just finished chapter 10, which is maps, hash maps, and skip lists. Chapter 11 is search trees. Chapter 12 is sorting algorithms. Sort and selection. Okay, that'll be a good one. We got to get into that one. 13 is text processing. 14 is graphs. 15 is memory management and B trees. And then that's it. So it's 15 chapters. So we're 5 chapters away from being done. So that's another one of my goals. So I want to finish this book before the end of my... Is there only 15 chapters? Is this all appendix? Yeah. Okay. Yeah, so I think we can do it. We got less than, 300 pages left. So I think we can do it. Chris gave us a problem here. Add two integers. This one here. Wait. Wait, what? Why is this so easy? Why is this so easy? Number 40 will be easy. Okay, Chris hand fed us a problem here. Chris. Oh my gosh, that's funny. Which one is it? Which one was it, Chris? Is that cheating? To do that easy of one? Add two numbers together? This is Leak Code. I just have a free account. I don't pay for anything, guys. Everything I've done for my learning so far is completely free. YouTube University, free books, free books, free books. You got to think of what do you think people learned out of before, YouTube University, before, they went to college, yeah. And what did they use to um, learn the material from college? Books. Everything is in books. So I'm following the same approach as our past programming fathers have done, and we're using books. 2235. Number 40, easy clap here for number 40. Easy clap, number 40. There you go, Mohan. There's your one more, boy. There's your one more. 2236. Watch that one be like really hard. Root equals sum of children. You're given the root of a binary tree that consists of exactly three nodes, the root, left, and child. Return true if the values of the root equals the sum values of its two children, otherwise false. Oh, they should have you warm up with these ones. They should have you warm up with this one for trees. Why'd they make this one so far down the list? This would be a really nice one to understand the whole kind of start to do trees. So in this one, you're given the root of a binary tree that consists of exactly three nodes, root, left, and right child. Return true if the values of the root is equal to the sum of its two values of its children, otherwise false. Return true if root dot value equal to root dot left dot value plus root dot right dot value. Oh, I forgot else false. Shoot, go back. Nice. Chris giving us the hookups on the easy leak codes. But these are fun though. Like this would have been a really, really good one to warm up with, like in terms of understanding, okay, I call left dot value, I call right, and I can access. So they should throw this one up at the very beginning to warm you up into trees before all these. They gave you like 10 tree problems in a row at the very beginning. Like look at this one right here. Like look, problems. Easy. Like they give you this. Binary search, binary in order traversal, same tree, symmetric tree, maximum depth, balanced tree, minimum depth, binary pre-order poster. They give you a ton of tree problems here. It would have been really nice to have that one like up here at the top. Is one liner not allowed? Copy and paste 141 on a 142 and I'll get it. What is that? What is 141 and 142? Linked list cycle onto 142, you said? We're having fun with LeetCode here. This comes in handy when you're building an NBT editor. What you referring to, Premiere? Thanks for stopping in tonight. If you guys are here on the stream, leave a thumbs up. Also consider subbing along. We just passed 1640. If you want to be number 1641, then go ahead and sub on up. Appreciate you guys for being here. Yeah, slow. We're diving into Git and really getting a real ground level understanding of Git. So we read chapter 1 of Pro Git today, live on stream with the first hour. It took us about 58 minutes to read chapter 1. Tomorrow we'll read chapter 2, and I'm taking notes alongside as we go here. So I'll push these to GitHub, and you guys can access these in my Discord link down below. But we are reading and getting a really good understanding of Pro Git right now. That's what we're reading right now. Thanks, Lo, for coming in. Unstoppable! Yeah, that really gives you some great ideas on how to get better at programming. Hall, what are you referring to, Premiere? Mahan, are we not allowed to do one-liners? I want to see what this one is. This is the problem of the day. Return the minimum number of operations required to make every element in numbers equal to k if it's impossible to make all elements. So an integer h is called valid if all values in the array. You're given an array and an integer. An integer h is called valid if all values in the array are strictly greater than h are identical. For example, numbers 8, 10, 8, 10, 8 is valid. A valid integer is h equals 9 because numbers index I greater than 9 are equal to 10, but 5 is not a valid integer. You're allowed to perform the following operations. Now select an integer h that is valid for the current values and numbers for each index I. Return the minimum number. What is this asking? It is impossible to make all the values equal to. Well, because you have one value that's less than. So on k equals 1, all of them would have to go up by. Okay, so we'd have a count equal to 0. We would say for I, or we'd have n is equal to the length of nums. What is k again? K is return the minimum number over equal to k. We're not given an h though? Wait, where does this h come in handy? An integer h is considered valid if all values in the array that are strictly greater than h are identical. For example, if numbers is equal to this array, a valid integer is h equals 9. Because all the values in the array are greater than the h value are equal to 10 and the 10. But 5 is not a valid because 8 and 8 and 10 and 10. Okay. Select an integer h that is valid for the current values in numbers. For each index I, where numbers index I is greater than that value of h, set numbers index I to h. Huh. So you're given a k value of 2. So you would say if the k is equal to 2, then you can increase the 2 and the 4 to equal to 5. This one's weird. I'm not really sure what this h and k thing means. So if a k is 2, well, it's equal, so there's no values that are greater than it, so it's impossible to make all the values equal to 2. With k is 1, all 4 values can be increased Yeah, exactly. I'm the same way, Mahan. Like, what is this saying? Like, who wrote this? I can't even like read this English. Yeah, we'll have to come back to this one. It sounds interesting though. 145 is the same as 144. You just need to call the function differently. Let's look. 145, you say. Oh, it's the next one up. We gotta save something for tomorrow, Mahan. Oh, h is the highest value in nums? Oh, okay. So if h is the highest value in nums, that's the value that you need to get up to match. So if value is less than nums, it's invalid. Pass. Right, so you'd say, so if h is the max value, which is 5 in this array, a k of 2 would need 2 values. So for I in range of n, if nums index I is less than Huh. So if you loop through, how can we determine which one's the highest first while we're also looping through? So you say save 5 immediately as highest. If the value so you have a highest or high is equal to nums at index 0. If nums else return yeah, right. So if you set the high equal to the first value in numbers, we would say we'd go 1 to n. We'd say if numbers at index I, this value is greater than 2. Well, if the numbers at index I is less than or is greater than high, then high is equal to nums at index I. Can I say this? High walrus operator equals to nums index I if nums index I greater than high. And we say if elif nums index I is greater than or equal to k, we're going to count plus equals 0 plus equal 1. This is like learning NumPy. You really got to read the whole entire document on each thing to fully understand what it does almost. So this literally the increment the highest value, or it could if you pulled it to. So this literally the increments the highest pulled it to. If nums index I is greater than or equal to k, we increase the count. So you just want to specify if k is 2, there are two values that are greater than or equal to 2. Do you just return count? You don't even have to do anything with high? Is that there just to throw you off? For -1, 3. For K1, 6 4. Count equals 0. Return count if count greater than 0, else -1. And then we have k is 2, should be 2 here. If why did output 4 here? If it's greater than or equal to, oh, it was all of those, but not equal to high. So do we have to do a pass to find the high value and then pass to Bro, Mahan, we did like 3 questions already you asked us to do. It's all right, bro. Chill. Um, right, so right. So how can we set the high? Right, so we need to get a high and then so we could say for we have to say high. So 2 loops to get a high, but they're not nested, so you're gonna say high is equal to max nums. If it's greater than k, but less than, and nums index I is less than high, count plus equals run. Oh. One, all 4 of those. Three. Here's 1. That's high. All of those. Only 2 of these. Why can't you match the high? Output should be 4. Output. Okay, see. Huh. So 5 is not a valid integer in this case because it is an integer that is an h value that is below other values, and anything that is above it, right, the 8, so you would have to have 10, 10, 10, 10 in order for 5 to be a valid. Hey, Med, how's it going? Thanks so much for joining me here. How you doing? So in this case of 1, all 4 of these, except for the 9, is the high. So we'll say this is 2 here. Oh, so it's not equal to, it's just, it's greater than k. And then you'll do the value itself if k less than high. Oh. Dang it. So now this is going to return. This will fail some test cases now. So I definitely have the wrong algorithm. Yeah. Gonna have to think about this one. NSM Bari, how's it going? Thanks so much for being here and joining me. We're at 1641 subs. Thanks so much for joining me. My name is Michael. I'm 26 years old. I have a degree in human biology and a minor in chemistry, and I work as a formulation chemist for a biotech company where I make controls of various different types, from urine, plasma, blood, a bunch of different types of controls for patient diagnostics. I've been teaching myself how to code for about 9-10 months now. We started today's stream by reading chapter 1 in Pro Git. We're going to read chapter 2 tomorrow, and then we solved a bunch of leak code problems here. So we've solved, I think, 3 or 4 so far, but we're stuck on this one, the problem of the day here. I'm just not sure what to do with this H. Handle the case when the array contains an integer less than k. If the array contains an integer less than k, oh, let's do this. So let's say n. Right? Let's just move it forward. That value is good, right? If the number is less than k, right? Copy is equal to n. So then we say, right, can we reduce n when, and So if the number is less than k, n minus 1, or copy minus 1, elif, or no, if nums index I nums index I is equal to the height, we're going to pass. So if it's less than k or equal to height, or nums index I is equal to high, then copy minus 1 will reduce copy all the way down. If k is equal to high, copy minus 1, return copy. So how can I create a copy of the variable without changing a reference? In this case, huh. Hmm. Sweet, Bari, thanks for coming in. I'm glad you got a referral from a friend. Thanks so much for joining me. No. So I thought that maybe we could use our our length and reduce the length down for improper values. So, right, if we know we have a high, a valid number is less than the high. Anywho, I'm going to take a pause from today, guys. We did a lot today. We did 3 hours. I was going to wrap it up at about an hour and 15 minutes, but you guys kept chugging me along. Thank you guys so much for pushing me to keep going. So today we completed and read chapter 1 of Git Pro Git. We're starting to really expand our knowledge into Git and understanding how we can better, use Git, especially when we're opening up our small business manager project into... Yeah, so when we open up our small business manager project into a open source environment for you guys to start helping out with if you guys would like to. After I submit it for my CS50 final project, right? This is our small business manager project that we've been building so far, all from scratch in Python and Tkinter. And so the Git knowledge will really, really help us to be able to, work together and collaborate on this across various users. So it'll be really awesome. And so this is our small business manager that we've been building. Tomorrow we'll probably work on the balance sheet portion and get that started. It's our last page we need besides the settings, obviously, but we have inventory properly being loaded. We have expenses properly being loaded. We have transactions and returns that are now properly being able to take place across the same item, multiple instances, and then those auto-generate and populate appropriately our income statement for the necessary values. So this is a really, really great project we got going on so far. We're almost done. We're about 85, 90% done so far. Just one last small feature on the balance sheet, and then we're done really with, and then just a couple of settings to allow the user to add some custom parameters, and then it'll be done. And so our Git knowledge, right, that we're doing right now will come in handy when we're pushing this and doing pull requests and working with other people on this, and just in general having a really, really good understanding. Reading this book page to page will really help us to really understand Git at a core level. And then we also completed, I think, 3 or 4 leak code problems today. We've completed 41 problems so far, so not too bad. I really, really appreciate you guys joining me here and hanging out. Mike, when is the 24-hour stream? I don't know, dude. I'll burn out. I can't burn out. You guys want me to burn out? Leave a like on the stream if you're here, if you're part of the late night crew. It really, really helps to keep YouTube promoting us and getting new friends in here to network with. So leave a thumbs up. It really, really helps you guys. And thank you so much for being here. Thank you, NSM Bari. I'll look forward to seeing you guys again. And no worries, Jacob. We're just kind of wrapping it up here. We started Git today, and we're really getting some good knowledge going. Yeah, I stream every day around 7 p.m. PST or 10 p.m. Eastern after my 9 to 5 job. Early afternoon in Australia. Oh, perfect. Nice. I thought you were in Canada, Jacob. You visiting back home? Thanks so much, NSM. Join the Discord. I have a Discord link down below, which has a complete roadmap of my entire learning so far completely for free. From all the books that you see me reading on stream, to my personal projects, to weekly updates and breakdowns of the courses I take, and provide you guys my code to my weekly problem sets for those courses. So feel free to join the Discord link down below, and it'll be awesome for you guys to network with us and just get access to all those resources for free. But anyways, thank you guys so much for being here on April the 8th. We streamed for a little over 3 hours, really diving in on Git, and it's going to be awesome when we get more knowledge on this. And I'm feeling a lot better on trees in general with leak code. It feels good. I'm understanding the recursive process of trees better, and just in general of how to go about with a helper function. It's really nice. So I'll see you guys tomorrow. Back